Hi, this is Aditya and this is my lab one report about charge tapes. The main purpose of this lab is to observe electrical interactions between two pieces of charge tape and to determine the excess amount of charge on the charged pieces of tape. The materials required for this experiment were tape, roller, a flat surface like table, and two objects for supporting a piece of tape. GlowScript was used to create a computational model to simulate the charge tapes and the interacting forces between them. A brief overview of the results is that the charge on each tape was found to be approximately 1.16 times 10 to the power minus 8 coulombs, and the number of electrons lost in each tape was approximately 1.3 times 10 to the power 10 electrons. Some fundamental principles which were necessary for this lab is the Newton's second law, which states that a system change in momentum is proportional to the net force applied, and Coulomb's law, which is used to describe the force of attraction or repulsion between two electric charges, and the gravitation force, which is used to calculate the attractive forces between two objects of mass. Initial conditions for this experiment were the mass of the tape was determined to be 2 times 10 to the power of 4 kgs. The length of the tape was 0.28 meters. Tape width was 0.02 meters. The tape area, which is this length times width, is this much. We also find the area of the atom. The number of atoms is just tape area over atom area, which we found to be this much. The charge tape used in the experiment was a positively charged one. We found that because it was attracted to a negatively charged pen. Here's the experimental setup. The system in this case is tape B. Tape B is the one which is floating in this image. The surroundings is tape A and everything else. The distance between two tape is 0.025 meters. Here are the images. Here's the ruler for reference. Uh, the main goal of this lab was to figure out the number of excess electrons. So for that, we first find the gravitational force, which we got to be this much. From this free body diagram, the gravitational force is equal to the electric force in magnitude. That's why we have the same value for the gravitational force and electric force. Using the Coulomb's law, we find the charge to be this much, and using all this information, we find the number of electrons lost, which is approximately 7.3 times 10 to the power of 10. This is the GlowScript model. This is where we find the charge using this line of code, and this particular function is used to calculate the electric field. This is the result of the code. As we can see, the red sphere is tape A, which we assume to be a point particle. The cyan colored sphere is tape B. The green arrow is the electric field, and the gravitational force is represented by the blue arrow. Uh, some assumptions we made for this experiment are that the air resistance and friction are almost negligible. The tapes are assumed to be point charges. That's why in the code we have represented them with red and cyan spheres respectively. We are basically using the monopole theorem here. Each piece of the tape had some amount of even distribution is another assumption which we take. If we consider these assumptions, there's always a chance for errors. Some of which include that the charges might be unequally distributed, leading to some calculation errors. Some amount of charge might be lost due to handling with bare hands and the environment the charge tape is in. And there's always rounding errors. So to answer the first question, what if electrons are positive charge and protons are negative charge? In that case, all the observations we made will remain the same. Although the charges are reversed, like charges will always repel and opposite charges will always attract. That is, in this case, then the negatively charged tape A will repel negatively charged tape B, and this piece of negatively charged tape will attract the positively charged pen. Uh, Another question, why is it important to handle charged tapes as little as possible? The charged tapes begin to neutralize. The more we handle it, the more neutral it becomes because of the fact that the tape has a deficit of electrons and will try to gain back all the electrons from one object to other. Thank you.